Okay, I should have waited until we did the change. Abdelfettah is an amazing speaker and joins us from Google. He's a cloud developer advocate. Leaving it to you.
Thank you. Hello, Jordan. Assalamu alaikum. So before I get started, I have to say something. This conference is probably the best conference in terms of how they introduce speaker I have ever been to. And I've been doing this for a while. So congratulations for the organization, the choice of the music. I've been hyped up. I am very tired. I've been traveling for 4 weeks. But let's do this. All right. My name is Abdelfattah in Arabic. But I've been living in Europe for 11 years. So I go by Abdel. And that's because my name in Arabic, Abdelfattah, has the A. And Europeans don't know how to pronounce that, right? So I'm a developer advocate at Google. I work on cloud and security. I co-host a podcast called Kubernetes Podcast by Google. And I'm also a CNCF ambassador, Cloud Native Compute Foundation ambassador. That's my Twitter/X. I mostly share pictures of me going for a run or eating food. And sometimes I do talks. I've been joking with some people earlier. I tell them I travel mostly for food and to run. And sometimes I do talks. That's just a happy coincidence. So I'm going to take you back a little bit on the memory lane. We're going to check a little bit how things have been progressing. The tech industry is moving very fast. And I'm going to take you a little bit on a history train. 2013, PyCon, the Python conference in San Diego in the US. Solomon Hykes, who is the gentleman on the picture, went on stage and revealed for the first time ever Docker, the technology that allows us today to build containers and run containers. So on stage, Solomon demonstrated Docker and the value proposition of Docker. And the idea was, you developers do not have to actually understand how Docker works. You do not have to understand any of the mechanisms under the hood that makes Docker happen. You just have a very simple file called a Docker file. You write a set of instructions, you run a command line, and then you have a container, right? The reality is, containers were not new back in 2013. People have been doing containers for a very long time. In fact, inside of Google, we have been creating containers for almost 25 years. Google is 27 years, and we got onto the containers stage very, very early in our existence. What Docker really did, which is a very good thing, is that it made containers easy. It made running containers easy for developers. Under the hood, the mechanisms, the components inside Linux that makes container happen, they existed for a very long time, right? And what containers really did for software is the same thing that physical containers did for the shipping industry. Imagine before we started using containers to ship stuff around, people shipped all sorts of items: bikes, cars, clothes, toys, food, drinks, right? And somehow people had to take all these items that are different shapes, different sizes, different colors, different weights, and fit them inside the boat, right? And then somehow transport them safely and unload them on the other side of the world. It was a logistics nightmare. It was a really big problem. Things broke all the time. Loading and unloading boats was very difficult and very it took a lot of time. So the shipping industry came with this idea of standardization. Let's create something called a container. I don't know if you know this. I think there is one person who knows this because you work at Maersk. But all these containers that are shipped around the world, they are standard size. There are 2 different sizes. I don't remember what sizes are, but there is basically full container and half container. And so later on, the people or the companies that make the boats, they just basically had to make boats that could fit those standard size containers inside the boat. And then the devices or the thing that we use to load and unload also have to be made to size, right? So what containers allowed us to do is take all these items we have to ship, put them inside a standard size box, and then we move the box around, right? And if you really think about it, that's essentially what containers in software does. It allows you to say, it doesn't matter what your software is, it doesn't matter what programming language, it doesn't matter the framework, containers doesn't care. You take all that code, tests, configuration, all that stuff, and then you put it inside a fixed size standard object called a container. And then the container will run the same regardless of which computer you're running on. Windows, Linux, Mac, Raspberry Pi, your phone, etc., etc. Today, there are actually more than 7 million people using Kubernetes. So I'm going to talk about Kubernetes in a bit. But there are more than 7 million developers that report using Kubernetes daily. And by 2025, Gartner have expected that about 95% of digital innovations are going to happen in the cloud. Containers opened up the world of cloud, made cloud easy, made cloud understandable, and made it appealing. There have been a lot of success stories, and those are not necessarily, I'm not listing these companies necessarily because they are using Google Cloud, but these are just a couple of examples that I am aware of. Probably the early example of a company that managed to scale a product very, very fast using containers is Pokemon Go. Have anybody here played Pokemon Go? Few of you, okay. You remember a few years ago when you were sitting in a park and then there would be a bunch of people just moving, looking at their phones, you know, maybe with a cable going to like a power bank in their backpack. You remember those days? That was crazy days. So the way Pokemon Go was developed, it was basically developed within 9 months. Can you imagine taking a game from nothing to 9 months and scaling it to hundreds of millions of users around the world? Containers made that happen, and Kubernetes made that happen. L'Oreal, the very famous fashion or beauty products company, also used containers daily. The Home Depot, one of the first companies actually that jumped on the containers and Kubernetes wagon to be able to scale their operations. PGS, this is my favorite example. PGS is a company that collects marine data, so they have those like big boats that go out into the sea, and they pull sensors to collect information from the bottom of the sea about oil and gas. So they're able to find information about where oil and gas is. So they had their own HPC, high performance computing, on premise, right? For the nerdy among you, they use Crayon XC40, which is a very popular model. So those high performance computers are very expensive, they consume a lot of electricity, and they are very hard to maintain, but they're also very expensive to acquire. And so the one that PGS had came to its end of life around 2020, and they were faced with the decision whether we want to spend hundreds of millions of dollars to acquire a new HPC or do something else. And they decided to do something else. They moved all their workloads to the cloud. Today, when they run their calculations on cloud, again, using containers and using Kubernetes, they peak at, and I'm gonna say the number and I'm gonna pause because I need you to process this number. 1.2 million virtual cores. That's insane. 1.2 million virtual CPUs. That's a crazy number. And they're able to scale up to this number and scale down within a matter of minutes. This is what containers and cloud allow people to do. So, the obvious question, what is a container? This is probably going to be the 20th time this year somebody explained to you what a container is, so please bear with me. The easiest way to think about containers is it's an abstraction layer, right? We used to take servers, put hardware, put operating systems, put applications there, and just run them. Then we, at some point, decided, well, why don't we do virtual machines? Because virtual machines are cool. So we started doing virtual machines, and it was still kind of difficult. VMs are kind of clunky, and they need people to know what they're doing, and it's like they require expertise, and they probably require licensing because a lot of those like virtualization software are very expensive. But what containers really allow you to do is, it doesn't matter what the VM is, it doesn't matter what the operating system is, you as a developer, you deal with the container, that's the interface. You put your application, or its dependencies, and its configuration into something called a container, and that container will run anywhere that there is a container runtime, right? They come with a lot of inherently good built-in features. Containers are by default short-lived. When you run a container in production, you run it with the assumption that that container might disappear at any moment in time, right? And you need to be able to recover from failure. And the fact that they are short-lived is one of the best features around security, because this means that if you discover a bug, you can actually fix it, patch it, and restart your application very quickly, right? They are immutable. Immutable means once you build a container, you cannot modify it. Or you could technically, but you should be probably using a software that allows you to detect if somebody is modifying containers in production. They come with a lot of defaults. There is actually a lot of things that are by default locked in container runtime, and you have to explicitly allow certain things to happen. And that's good for security. And they come with some built-in isolation technologies. So if you run multiple containers in the same host, they are typically isolated from each other. There is still some bugs discovered daily in all the container technologies that exist today. You could still technically execute what we call a container escape maneuver, where you hack inside the container and then get out of the container and then take over the entire host on which you're running. That's still a thing that people do, but we are getting better and better from a technology point of view in preventing these kind of things from happening. The most important thing that containers did is that it solved the problem of it worked on my machine, right? How many people here have faced this problem before? Right, all of you, right? Good, good. I'm talking to the right crowd. So instead of basically facing the problem of it worked on my machine, we just ship your machine, right? So your machine is the actual container. And most probably, most of you don't know how containers work, and you have to explain this to your managers. So I hope I will be able to help you with this talk. There is also another shift that have been happening in the tech industry in the last few years, and that's basically the fact that we are expecting developers to do more, right? We used to be, and when I say we, I'm talking about people of my age. I'm almost 40. I've been in the tech industry for 15 years, so I consider myself old school. I am not COBOL old school. I am C++ old school. This is very important, okay? But I am learning Rust because I still want to be cool, so, you know. So back in the days, you just write code as a developer. That's all you have to do. You write code, you ship code, and then you go home, right? And you probably write more code because, let's face it, we don't have a social life as developers. Our hobby is just writing more code. Anybody relates? Okay, good. Most of you, good, good. I love this because it doesn't matter really which country I am in. There's always somebody relating to this. Then we started using cloud. And now we're expecting developers to not only write code, but to know how to configure cloud. They need to understand platform as a service, infrastructure as a service, software as a service. They need to know security. They need to know front-end, back-end, databases, distributed systems. They need to be full-stack developers, right? The reality is, I don't think that there is full-stack developers. There are probably 9 of them in the world, and they probably would cost you $500,000 to hire. But developers are trying to actually do more, and that's probably not a right approach, in my opinion, as a tech industry, as we're progressing. Now with AI, it's even worse, because you want your developers also to know AI, and to know Gen AI, and to understand what an LLM is. And also, another shift that have been happening in the industry is that the way we do software development is quite different, right? The developer used to own the entire life cycle of an application, including the design phase. But now we have all these sorts of like roles, like an architect, a UX, a UI, a front end, a back end, a database, blah blah. All these different kind of interfaces, all these different teams that have to talk, collaborate, work together to build and ship software, right? And that's another inherent complexity that the industry is going through, and we're gonna go through and face as we progress further. So, as organizations are facing these kind of complexities, there are 4 key decisions that you have to look at and you have to care about before choosing any sort of technology, before switching to containers, before deciding to use containers, and before really even writing your first line of code. How are you gonna make your developer experience better? What's the right level of abstraction for your developers so they don't have to do everything? What's the right amount of speed and scalability, right? I think most of you are familiar with this phrase of like, move fast and break things, right? You probably don't want to break things, but you still want to move fast. So what's the right amount of speed? How much do you ship? Do you ship once per day? Do you ship once per month? Do you ship once per week? Or once per year? Which, if you are shipping once per year, you probably should not be in this room. How do you manage cost? And how, and when do you use containers? This is actually a very interesting thing. It still amazes me today that I meet people that go, oh, you know what? We're doing containers for everything in our application except databases. And I go, why? And they go like, well, containers are not good for databases. And I'm like, said who? And said why, right? So I'm gonna talk about that a little bit. Let's start with this, the right abstraction layer. We have been going through a lot of iterations of trying things out. We in the past, again, talking about myself in the C++ world, we used to have developers and operations, right? You develop code, you ship code somewhere, it's the ops people problem. It's not your problem anymore. Well, it's your problem when there is a bug. But as long as there is no bug, it's not your problem. Essentially, no news is good news, right? Then we eventually, at some point, decided, let's do DevOps, because that's cool, right? Let's break the wall. Let's put these two teams together. Let's hire people who can own the entire stack, from development all the way to production. And the latest iteration in this saga of trying to move fast and give people a proper developer experience is this thing called platforms, right? Have you heard of platforms, I think? Some of you, probably, good. Okay, so the idea of platforms is essentially, we will have a team on one side building a platform, and I'm gonna take a pause here to admit something. I still don't understand what platform means, right? The word platform, I don't think anybody understands it. If you take 10 people in the same room and ask them the question, what does platform mean? You're gonna get 25 answers, right? So we'll take people, we'll ask them to build a platform, whatever that platform is, right? And then we take the application team and we'll make them use the platform, right? Sounds simple, right? The problem is, who defines what a platform is? Who owns the platform? What features go into that platform? And how does developers or how does application teams interact with this platform? But because I am a nerdy, curious person, when I found this slide, and this is coming from our internal slide deck, I could not resist by noticing one very, very crucial detail. You see this little line here that splits the platform to the application team? Doesn't that sound like what we used to do before when we just had ops and dev, right? It's essentially the same idea. There is the ops team, and then there is the dev team. Now we call them the platform team and the application team. It's essentially an iteration over the same thing. And this is just one very important observation. Our industry, the tech industry, acts like a pendulum, or acts in a cyclical way. We try things, we improve, we change how we look at things, and then we go back to square one. And we try again, improve, go back to square one, try again, improve, go back to square one. So 2 observations out of this cycle. First of all, is that most of us in our lifetime or in our career, we will probably only notice one iteration. Because an iteration takes on average 10 to 15 years. Most people work about 20 to 25 years for their entire career. This is assuming you don't just quit and open a farm and raise some chicken, because a lot of people in the tech industry that do that at some point. That's kind of like as far away from a keyboard as things can be, right? And so most of us will only notice this shift once. And we are in the middle of this shift where we're going back to the platform time, which essentially is ops and dev, right? The second thing is, when I go around, do talks, attend conferences, and especially when I go to universities, a lot of time people, especially young people, so by young I mean graduated after 2000, I think they call them Gen X or Gen Z, right? So they come and ask me, which technology should I learn so I don't feel irrelevant in 20 years? And most of my answers are like, it doesn't matter. You're never going to be irrelevant. You're never going to be long enough in the industry to notice 2 iterations of these processes, 2 cycles. Your skill is still going to be relevant. If you are a developer, as long as you know how to write code and how to learn how to write code in programming languages you're not familiar with, your skill is still going to be valuable, right? AI is not going to replace you, regardless of what people are saying. There was a company that tried to do that. They created a thing called Devin. You remember that one? The AI software engineer. Have you looked at the latest reports? It managed to fix 3 out of 10 GitHub issues. And for one of the GitHub issues that it was given, it took them 2 hours to fix it. It took the AI 2 hours to fix a GitHub issue that would have taken the developers 30 minutes, right? So it's not going to replace us. Let's just face it. So focus on building skills around technologies that are reusable. And technologies that are reusable are things like development, frameworks, programming languages, distributed systems, things that are going to be relevant regardless of how the future looks like. I'm going to skip this slide. So in 2014, there was a conference called PyCon, not KubeCon, sorry, this is a mistake on the slide. And we revealed Kubernetes. So that was the first time Kubernetes was actually put out to the world. By the way, if you're curious, in June, 6th of June this year will be the 10 years anniversary of Kubernetes, because the first pull request that pushed Kubernetes to the world, the first commit, was the 6th of June 2014. Then somewhere down the line in that year, we just revealed Kubernetes, it was at DockerCon, and the rest is history. Kubernetes was introduced with the idea that we will make infrastructure abstraction easy. You as a developer or as a user, you just have an API and a command line and maybe an interface. You talk to the interface or you talk to the API and you express intent, right? The whole idea of Kubernetes is based on this thing we call the promise theory. The promise theory is the idea that when you deal with the system, you ask the system to do a thing, you express your intent, and the system will promise that that intent will be executed eventually. If you have in the past used Kubernetes, you know that the way it works is that you tell the system, I want to deploy X. I want to run 3 instances of this application. And then you just don't do anything anymore. So you express your intent and you let the system deal with that intent. If anything breaks, the application will be restarted. If you need to scale your application up, it's a simple command to scale it up. If you need to scale it down, it's not a simple command, etc., etc. So the ability to achieve speed without compromising scale and stability. So when you are dealing with applications at scale or with application in production, there are few metrics that are very important to keep in mind and to track. 2 metrics for speed are the deployment frequency, how frequently do you deploy, and the lead time for change. So how long it takes you between making a change in the code base and that change getting to production, right? The other metrics in terms of stability is the time to restore a service. So once things fail, how long it takes you to go back to a working state. And then the change failure rate. So whenever you introduce a new change, how often does your change introduces a failure? And how often does your change introduces success, right? These 4 metrics are actually the metrics that are part of this thing called DORA, the DevOps Assessments Research, or DevOps Research and Assessment. So DORA is a company that started and eventually got acquired by Google, and they introduced a framework which allows organizations to track those 4 key metrics. And those key metrics essentially are the balance or are what you need to track to strike a balance between moving fast and being stable, right? If you are leaning more toward the left side, if you are just moving as fast as possible, so your metrics on the speed side are very high, but your metrics on the stability side are very low, it takes you longer to restore, each time you introduce a change it fails, then you're probably on the wrong track. If you are on the right side, like you release once a month, but your application is super stable and you never have problems, then you're probably in the comfortable side. What you are trying to do or what you want to do is be somewhere in the middle. You are able to release changes very frequently. You are able to redeploy and deploy the app very frequently. But at the same time, your application is stable and your users are not impacted, right? And so there is a tool actually that have been in the use for a while now. It's a concept called the service mesh. Have anybody here heard what a service mesh is? Few people. All right, cool. So a service mesh itself is actually not a technology. It's just a term, just a word, right? There are multiple tools that can be a service mesh. There is Istio, Linkerd, Cilium. There is a lot of open source software that can do a service mesh. But a service mesh is what it is essentially, it's an abstraction layer on top of networking that allows you to introduce change while keeping track of those 4 metrics we talked about, right? So you deploy your application on top of an abstraction layer, and that abstraction layer allows you to do a lot of things like A/B testing, canary deployment, where canary is when you introduce 10% traffic to the new version of the application and you keep track of the latency, the success rate, the failure rate, etc., etc. So this is a very effective tool that can be used to track the metrics to be able to strike the balance between speed and stability. What about cost? So there have been also a shift recently, and especially with COVID, a lot of companies are actually getting more and more cost cautious, right? We want, and I want to like stop here to just make something super clear. When we say being cost efficient, it doesn't necessarily always mean spending less. It means most of the time getting more out of what you already spent, right? Like cost efficiency is not about reducing cost. It's about getting more from what you are paying. It's about paying the same bill to your cloud provider, but being able to scale up more, being able to have more users. Because by cost optimizing the way you run your application, that will most of the time translate into direct business impact. You make more money in your business, right? So most of the time when people talk about cost, if people are talking about it with the idea of we want to reduce our bill, that's probably the wrong approach. The right approach is to say, okay, let's forget about reducing bill. Let's try to see if we can do more with what we already have. If you can reduce the bill, that's good. If not, that's also fine. So there have been a lot of efforts. There are a lot of ways you can approach this. There is this whole new cultural change, role, whatever you want to call it, which is called FinOps, financial operations. These are people typically that have technical background, but they also have financial background, and they're able to look at your cloud bill or look at your utilization and go, okay, you can optimize this, maybe reduce this, maybe turn off this service and turn on this service, et cetera, et cetera. But there are also things like how do you right-size your application? How do you make your application is not too big? How do you make sure your application is not too big or not too small? How do you scale down when you don't need, right? If you're using cloud, you most probably want to be able to scale down your application when there is no users, right? I mean, most probably, most organizations build applications that are only used a part of the day. They're not used 24 hours. If you are building an application that has consistent traffic for 24 hours, you are probably Google, right? But most companies don't do that because most companies operate and they target a specific market. And that market are people that basically have 16 hours of awake time and 8 hours of sleeping. So being able to look at how you can scale down your application to optimize your cost when there is no demand is one interesting approach toward financial optimization or cost optimization. Bin packing, being able to jam or pack more applications in the same set of resources you have by optimizing the application itself, by reducing memory, maybe the memory footprint or the CPU cycles, all this stuff, all these approaches that you can do toward making sure your application is as efficient as it can be, all goes into cost optimization, generally speaking. And then the last thing, are containers only good for stateless applications? The reality is not. So today, 4 out of the 5 top AI companies, and I'm not going to mention names because I'm not allowed to, but 4 out of the 5 top financial companies uses Kubernetes and containers to run their applications, to train the models and to execute the models, right? These companies were able to release their LLMs or their chatbots or whatever you want to call them very quickly because containers allowed them to do that, because they could build, ship, train very, very quickly on top of existing infrastructure that is easy to use, powered by Kubernetes, because of the flexibility that containers give you, because of the flexibility that something like Kubernetes give you. If Kubernetes, this is my own personal opinion, I think that if Kubernetes and containers did not exist, it would have probably taken OpenAI 2 years to release ChatGPT instead of 6 months, right? So, to resume this part of the presentation, if you are going toward containers, if you are planning to use containers and Kubernetes as a way to abstract away your application, keep these things in mind. Having a business case that is oriented around value, thinking what value am I going to get from this shift or from this movement. There is no such thing as one approach fits all. Not everybody has to be on cloud and not everybody has to be on premise. There is a place for both. I was talking to somebody earlier, a Jordanian company, and we were chatting, and they were like, yeah, we just use virtual machines on top of a hosting provider in Germany. And I'm like, that's fine. If that works for you, if that allows you to scale and allows you to still ship applications, you don't have to use Google Cloud, you don't have to use AWS, you don't have to use Azure. I really do not appreciate people on the internet the internet is 99% opinions and 1% useful informations. But I do not appreciate people that have like this very extreme takes, which is like, we have to go cloud or we have to go on-prem. There is probably a place for both, and it's fine to use both. Take a platform view. Again, if somebody understands what platform is, you can tell me later because I still don't understand it. Strategically push the envelope. Try to always push for more. Try to always do more. Try to innovate, keep up, and create shared responsibilities. Make sure that everybody in your team is involved and everybody has a say and everybody can voice their opinion. I'm going to leave you with two last things. Security. So you remember the example I talked earlier when I said university people come to me and they ask, what do I want? What can I do? You know, how can I be relevant? Like 1 out of 2 times I tell people go to security. Because the reality is, regardless of how the tech industry progresses, there will always be somebody who will use admin as a username password, right? That's not going to change anytime soon. And the reason why it's not going to change is because we're humans, and humans are really bad at doing things. Computers are much better than us, but they cannot think, and that's the problem. So there have been a lot of these type of attacks very recently. In the cybersecurity world, a lot of times people talk about defensive security, offensive security, you know, making sure your system is insulated, making sure nothing is exposed to the internet that doesn't need to be exposed. But a lot of times people forget that there is more than one way you can get hacked, and there is more than one way somebody can get into your system. And I'm going to pause here and give you a very, very recent example. Did anybody heard recently about the hack or the vulnerability in a library called XZ? Few. Okay, for those who haven't heard, you know OpenSSH, right? Good. So when you are using OpenSSH, one of the things you can do with OpenSSH is copy files, right? You can copy files from one server to another using OpenSSH. When you use OpenSSH to copy files, under the hood, the files are compressed, and they're compressed using a library called XZ. There was a vulnerability that was discovered recently where when there was investigation done to try to understand where that vulnerability came from, they discovered that the person or the group of people who introduced this vulnerability started working on it 3 years ago in the open source space. So they created a GitHub account and they contributed legitimate code to XZ, and through these 3 years of contribution, they introduced a backdoor to XZ that allows anybody who is using OpenSSH with XZ to copy files to basically ship those files to a remote server, right? And this is what we call software supply chain problem. Because in the software supply chain, the problem we are facing as we are going further is everybody depends on everybody. No one here is writing a curl library or a mat library or an HTTP library, right? You just import it. Whatever programming language, you go to your dependency management and you go import mat, right? And you use that mat library to do mat calculations, or import HTTP, or import whatever library you want. The question is, do you know where that library is coming from? Do you know who built it? Do you know if it has vulnerabilities? Who scanned it? How was it built? Like 99% of the time, you're never going to read the code of your dependencies. You're just going to import some dependencies and use them. And 99% of the time, you're just going to actually copy your dependencies from Stack Overflow. Because let's face it, that's what most developers do, right? We basically copy stuff from Stack Overflow and make it work. So this whole supply chain, the whole way we ship software from one place to another is vulnerable at so many levels, and we need to do better. We need to be more aware. There have been an increase in this number of attacks very recently. Those are just some numbers, like 650% surge in OSS supply chain since 2021. There is an effort that have been started by a bunch of companies called SigStore, and SigStore is a community effort to try to solve software supply chain problems. So they introduce tools and processes. These are just some components that can be used. I'm not going to go through the details. I'm going to share my slides later, and you can look into them. There are just components that allows people to be able to do things like sign-in, for example. So you will be able to sign an artifact, publish it, and whoever needs to download and use that artifact can verify the signature so that they can trust that it's coming from the proper source, right? There is also another efforts that have been started as part of software supply chain security called SBOM, right? Software Bill of Material. I have a very stupid way to explain what SBOM is. And whenever I go somewhere, I go on the internet and I look what's that country's most popular dish. I think for Jordan, that would be mensaf, right? Good. So imagine mensaf is a dish. You want to make mensaf. What do? You go buy ingredients, and then you have a recipe that you follow, right? And it's most probably your grandmother recipe, right? Good. In software, ingredients are the libraries, right? The instructions to make the dish is what we call provenance, or the actual set of instructions that have been followed to build the software. The list of ingredients are the SBOM, the software bill of material, right? So with SBOM, essentially what you are doing is you are shipping a piece of software, and you attach to that piece of software the list of ingredients, the list of libraries, so that's the SBOM, and then the way that software was built, right? And this way, you have a way to go back in time and say, for this particular package, these are the list of dependencies inside. You don't have to open the package to look inside. You can just read the file attached to look at the ingredients. Make sense? All right. I'm almost running out of time, so I have to move a little bit fast. So I'm going to leave you with this. I have couple more slides. This is my director at Google, Richard. He's pretty cool. He basically put out this statement on Twitter at some point, which says, cloud-native software is built for scale, built for continuous change, built for tolerance, failure, to tolerate failure, and built for manageability. Containers give us the possibility to achieve this. Scaling is easy, changing is easy, tolerating failure is easy, managing applications through containers is easy. Cloud native is the future of how people are building software. Yes, there are still people doing COBOL. Yes, there are still people doing C++, but those applications are going to change in the future. And there will be only cloud native way of building applications going further. Last thing I'm going to leave you with, this is because this thing have been becoming kind of popular very recently. I think most of you have heard of WebAssembly, right? Most of you probably know WebAssembly as a browser technology, right? So it's basically something that allows you, it's a runtime environment inside your browser that allows you to run native code. Like you can write an application in C++ or in Rust and run it inside the browser, right? So what have been happening recently, so this is what WebAssembly is, instruction-based format, virtual machine. It's the key feature that WebAssembly allows is portability. The whole point of WebAssembly is that the runtime inside the browser is specific to whatever laptop you're running on, but the application itself is very portable. Once you build the application, it doesn't matter if the user is using MacBook, Linux, Windows, ARM, x86, Intel, the application will just run. So what's happening now is that there is a move toward taking WebAssembly and its runtime and using it as a backend technology. And this is something called WASM, WebAssembly modules. Come on. So again, back to Solomon Hykes, the person who wrote Docker. He put out this tweet back in 2019 saying if WASM, so WebAssembly modules, and WASI, WebAssembly System Interface, I'm going to explain what that is, existed in 2008, we wouldn't have to write Docker. Because the whole point of writing Docker was portability, and WASM and WASI already give us that portability. So if this technology existed back in 2008, Docker would probably have never existed. There is a very cool report on the CNCF blog about this from 2022. I'm going to let you go find the link and read it. It talks a little bit about how this space is moving, how people and companies are adopting it. There is even companies today that offer hosted WASM, so fully managed WASM. So outside the browser, what it is really is basically taking WebAssembly, the technology in the browser, taking the runtime, and making it run outside the browser. WASI is very simply the addition to WASM that would allow an application to be able to talk on the network and to manage file systems. Because when you write a WebAssembly application inside the browser, the application inside the browser is sandbox. It cannot talk to the network. It cannot make API calls. It cannot write or read from the file system at all, right? But as a backend technology, I/O and file systems are important, right? So WASI, the WebAssembly System Interface, is the addition to WASM that would allow WASM to be a good backend technology. I'm going to skip through the slides because I don't want to bore you anymore with this. I highly recommend you go look into it. The only thing I'm going to say, you're not going to, I do not recommend you to go tell your manager, let's switch everything to WASM, because this technology is still in development, but keep it in mind and look at it and maybe try it out. I've been trying WASM at home because I'm learning Rust and it's pretty good. So just keep it in mind. Yeah, blah, 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 smaller applications, more secure, etc., etc. I'm going to skip through those slides. It's probably the future. This is how I like to describe it. We are in the container space. WASM is going to be probably the future going further. And with that, that's all I have for you. Thank you very much. Can you leave the slides for a second? The QR code is my LinkedIn profile if you want to add me. And thank you very much. Thanks for having me.
Thank you, Abdelfattah.
Thank you.